Dad told me to do IXL, but like half of the world disagrees, so I'm going to be doing Khan Academy. And I'm going to add some no copyright music in the background so that you don't get bored. It turns out that it was paused the whole time. This music's made by Larry Poppins in the video called Tommy Nut Has the Voice of an Angel, and I've also watched through this video.
Add, subtract negative numbers, but we're going to give a lot more.
He's just telling me how to add and subtract negative numbers. Not negative numbers together, just negative numbers. Here's a numbered line that should be familiar. It starts at 0, counts up from there. Well, thank goodness. IXL, it's more of a reviewing website. And, oh, okay, you already know it. Answer these kind of stuff. But in this one, it actually teaches you. And you can skip it if you want. You know, keeps doing things that she doesn't know how to get out of. If we keep going to the left, we'll get negative numbers. Negative 1, negative 2, negative 3. Okay, gotcha. Let's correct this. Move the dot to negative 4. Wow, that's actually kind of cool. Check. Ooh, next question. How many questions? Oh, 3. Move the dot to negative 8. Wow. Check. Next question. I like it. Move it to 6.5. What was it? That? Okay then. Alright, gotcha. Fine. Why do we need negative numbers? It helps us describe values less than 0. Login as just around the room. Janelle is very young. When the temperature is 8 degrees below 0, it is negative 8. Okay. How would a bank represent a withdrawal? We check. Next question. How would losing 15 points? Boom. Check. Next video.
On the number line. So the point, the dot right now is at 0. And let's see, this is negative 2, this is positive 2. So each of these big slashes look like it's 1. So this would be negative 1, negative 2. This right over here would be negative.
I mean, I know how
so we're going to go a little bit more negative than negative 0.5. That would be negative 0.6. We want to go another 10. And so that looks right about negative 0.6. Let's do a couple more of these.
So.
Move the orange dot to 1.9 on the number line. So it's
is this
the same
Academy?
scale as in the previous
This
example.
is a great preview because I don't see a point system.
This is 0.5, 1,
Get 3 correct.
1.5, and 1.9 is only going to be a tenth less than 2. So it's going to be, let's see, that's 2, so a tenth less than that. And I'm assuming that it's locking us to the tenths, and it looks like it is. So that looks pretty close to 1.9. Let's do one more of these. Move the orange dot to 0.5 on the number line. Well, that's, once again, we have the same scale. It's important to always check the scale. And this right over here is 1, so 0.5 would be halfway. It's that little small mark right over there.
Okay. I just needed to check because every 5.
Plot the following numbers on the number line. So the first number we have here is 5.
Fractions.
And so 5 is 5 to the right of 0. 5 is right over there. That's our 5. Then we get 1/3. 1/3. So 1/3 is between examples in the next video. And we're actually going to see what these two.
It's night already. I want to go to sleep. Yes, sir. It's tiring doing things. Next. decimals and fractions. Yes.
Between 0 and 1. And we can actually split this into thirds. So that would be 1/3, 2/3, and then 3/3, which is 1. So 1/3 is going to sit right over there. It's 1/3 of the way from 0 to 1. That's 1/3. Let me write that. That's 1/3 right over there. And we have negative 1.2. I'll do that in this blue color. Negative 1.2. So negative 1 is right over here. This is more negative than negative 1. It's negative 1.2. It's negative 1 and then another 0.2. So it's going to be right over here. So this is negative 1.2. 0 is pretty straightforward. 0 is right over there. It's even labeled for us at 0. 5 is labeled for us too at 5. So we have negative 2 and 1/4. So let's go to negative 2. Negative 2 is here, and it's going to be, it's more negative than negative 2. It's negative 2 and then another negative 1/4. So it's negative 2 and then we go 1/4 of the way to negative 3. So negative 2 and 1/4 is going to be right over 4.14. And 1/4. And then finally we have 4.1. 4.1. So 4 is right over here. 0.1 is another tenth greater than 4. Another tenth on the way to 5.
What do they use to write?
4 and 1/10 is going to be right over here. 4.1. 4.1.
Yeah, that's fine. Number opposites.
What I want to do in this video is think about what it means to have an opposite of a number. So let me draw a number line here. So let's draw a number line. Let's put some numbers.
Where are these energy points?
So we can
I lost
start
them
at
all
0.
because I closed the page on
Right,
accident.
positive numbers. 1, 2,
Hopefully they don't mean anything like crate keys.
4, 5. As we go to the left, we get more and more negative. So negative 1, negative 2, negative 3, negative 4, and I could keep going on and on and on. So let's pick one of these numbers. Let's say we pick the number 3. What is going to be the opposite of the number 3?
Probably negative
Well, the
3.
opposite of the number is a number that's the same distance from 0, but on the other side. 2, 3, negative 4. Point out there.
Okay, this one's pretty straightforward. I mean, it's pretty
Or
easy.
negative 1. Or another way to think about it.
The opposite of... Uh-huh. What's the opposite of 2? Negative 2. Yep. Next. Opposite of 5. Negative 5. Next. Opposite of 0.93. Oh, I don't know. Negative 0.93. And just 8.3. Okay. I like this much better than I excel. I'm not bashing my head on the computer. Not like I already did that. Challenge problems. What is the opposite of A? E. Heck. Opposite of A. Is it not E? Oh wait, negative A. It's the opposite on the number line. Man. Opposite of A. 0. That's 1.5. Negative 1.5. You joking? Kidding me? Yeah. Oh, choose all of them. A equals E. Hang on. Close enough. What is the opposite of a number? Oh, where am I? Okay, what is the opposite of a... I don't understand how this could possibly be hard unless there's a number line. Just remove the negative mark. Well, which point represents the opposite of 0? Opposite of 0. Move the dot to negative c. 1/2. So this. Oh. Negative c. Problem 4. What's the problem? Minus negative a. Forgot to click the loop button. Sorry. I still recording? Just wanted to check. Okay. Negative a would be negative 6. Oh. A minus negative a, 0? Okay. I don't know. This means the opposite of a number. What? You could have just said that. What can we say about point E? E equals negative a again. Okay. Negative symbol.
In another video, we've already talked about
You could have said that before I answered wrong.
what an opposite of a number is, but we'll review it a little bit. If we start with a positive number, say the number 4. If you have a number, this is just this. Well, 4 is 0, so its opposite is going to be 1, 2, 3. Or another way to think about it, if you have a positive number, is that opposite of 4. So let me write this down. Opposite. One way to think about it, this is the number that is the opposite of 4. So let me write this down. So if I write negative 4, negative 4, that literally means, so you can take this negative symbol as meaning opposite. Opposite.
Not the way you write, it's very neon.
Of 4. Opposite of 4. If you were to say negative, instead of saying a specific number, let's just say a letter that could represent a number.
Negative
If I said
a.
negative a, opposite, be any number here. A is, and so negative. Put that in positive 3. So this is equal to positive 3.
Okay.
Or
Negative. Absolute value,
Find
exactly.
the absolute value of x when x is equal to 5, x is equal to negative 10, and x is equal to negative 12.
What?
So the absolute value, it's almost, the way of writing it is almost more complicated than what it really is. The absolute value is really just the distance of x from 0. Distance from 0. So let me just draw a fast number line over here. So
That's
if
a
I were
pretty
to
straight
first
line,
just put
actually.
0 right over here, since we're thinking about the distance from 0. So let's just think about the absolute value. Let's think about the absolute value of x when x is equal to 5. So that's equivalent to the absolute value of 5. We just substituted 5 for x. The absolute value of 5 is the distance of 5 from 0. So you go 1, 2, 3, 4, 5. 5 is exactly 5 to the right of 0. So the absolute value of 5 is just 5. Now, and I think you already get to see this is a pretty straightforward concept. Now let's do something a little bit
Is that it? X equals 5, so that one's 10.
more
Oh wait,
interesting.
that's
Absolute
negative
value
10.
of negative
So
10.
negative 10.
Just go negative 8, negative 10. Absolute, just do all the we can draw over here. This negative 11, negative 12 is right over here. It is 1,
okay.
2, 3, 4, 5, 6, 7, 8, 9.
Okay, it
10,
is simpler
11,
than 10.
12.
Gotcha. It seems to be quite obvious. Same thing with negative numbers, also for blah 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 blah. What's the absolute value of 3? 3. What's the absolute value of negative 3? Also 3. What's the absolute value of 4.7? 4.7? Negative 3.4. 4. What's the absolute? No. Absolute value symbol. The symbol for absolute value. The absolute value of negative 6. We could just write line negative 6 line. Oh, so that's what the line is for. Nobody told me what this line was for. I thought it was just so I could write things coolly. Yo. I've actually never used it unless I'm trying to do something like this. What is, okay, 7. 13. This is the easiest one so far. 8. 8. This is only hard if you accidentally type something wrong. That's okay. There's no point system that pushes me back. I love. A is less than 0. True. True. False. Oh wait, there, check. Ah! The distance to A small 0. Okay, I was just guessing now. A. I read the symbol wrong. A is less than 0. Value. Okay, next. No, this is
Some examples comparing absolute values. So let's say we were to ask ourselves how negative 9, the absolute value of negative 9,
You're probably supposed
how
to.
that compares.
Although I am learning a little.
The absolute value of, let me think of a good number. Let's say the absolute value of negative 7. So let's think of negative 7 is on the number line. Let's think with the absolute value. Of ways to think about it. 9 right over here. Now, when you take the absolute value of a number, you're really saying how far is that number from 0, whether it's to the left or to the right of 0. So, for example, negative 9 is 9 to the left of 0. So the absolute value of negative 9 is exactly 9. This evaluates to 9. So the absolute value of negative 7 is positive 7. And so if you were to compare 9 and 7, this is a little bit more straightforward. 9 is clearly greater than 7. If you ever get confused with the greater than or less than symbols, just remember that the symbol is larger on the left-hand side, so that's the greater than side. If I were to write this, and this is actually also a true statement, if you took up these without the absolute value signs, it is also true that negative 9 is less than negative 7. Notice, the smaller side is on the smaller number. And so that's the interesting thing. Negative 9 is less than negative 7, but their absolute value, since negative 9 is further to the left of 0, it is the absolute value of negative 9, which is 9, is greater than the absolute value of negative 7. Another way to think about it is, if you take the absolute value of a number, it's really just going to be the positive version of that number. So if you take the absolute value of 9, take the absolute value of 9, that equals 9, or the absolute value of negative 9, that is also equal to 9. When we think of it visually, that's because both of these numbers are exactly 9 away from 0. This is 9 to the right of 0, and this is 9 to the left of 0. Let's do a few more of these. So let's say that we want to compare the absolute value of 2 to the absolute value of 3. Well, the absolute value of a positive number is just going to be that same value. 2 is 2 to the right of 0, smaller number here. And so we clearly get 2 is less than 3, or the absolute of negative 8 to the absolute value of 8. Well, one way to think about it is that they're both 8 away from 0. This is 8 to the left of 0, this is 8 to the right of 0. So both of these things evaluate to 8. Absolute value of negative 8 is 8. Absolute value of 8 is 8. And so clearly 8 is equal to 8. Let me do a couple more examples. Let's say I want to compare the absolute value of negative 1, and I want to compare that to... In this video, we're going to try to figure out what 1/2 plus 1/3 is equal to. And like always, I encourage you to pause this video and try to figure it out on your own.
2, 5/6.
Half and 1/3. So this implies that's going to be equal to. And a good and the numerator. The green part, which you could do as the numerator, I now. So this is the same thing as 3/6.
Wait, what happened?
As a whole, then we have shaded in half of it. And if you want to visualize 1/3, it looks like that. So you could, couple things is, we know how to add if we have the same denominator. So if we had a certain number of halves here and a certain number of halves here, well then we would know how many halves we have here. But here we're trying to add halves to thirds. So how do we do that? Well, we try to set up a common denominator. 2/6. Let me just start with 1/2. And I made this little fraction bar a little bit longer because you'll see why in a second. Well, if I want to express in terms of 6, to go from halves to 6, I would have to multiply the denominator by 3. But if I want to multiply the denominator by 3 and not change, so these are now 6. So, well, the way that I could do that, it's 1/3. I would want to take each of these thirds and make them into 2 sections. So, to go from thirds to 6, I multiply the denominator by, multiply the numerator, turn into 2. What is it? Is it right over here? This is 3/6, 1, 2, 3, plus 2/6, 1, 2, gets us to 5/6. You could also view it as this green part was the original half, and this gray part was the original 1/3. But to be able to compute it, we express both of them in terms of 6.
Okay.
Let's say that we have the fraction 9/10, and I want to add to that the fraction 1/6. 1/6.
I can do that. Well, I should get a pencil instead of a pen. Just kidding. Messy. That's probably 60. That's a big number. 9 times 6. 64. I did this earlier today. I did math while playing Skyblock. I was thinking, how many trees do I gotta chop for an enchanted log? Yeah, I was playing Lefty PvP because Hypixel banned me. 10. 64 for a stack. 64, 60, or 60 and 4 and 1. 1, 4, and the bottom number is 60.
What is it?
Actually, it'd be more of a look like the 2. So 30, 30 and 32. That can be simplified.
This, what is this going to equal? So when you first look at this, you say, oh, I have different denominators here. It's not obvious how I add these. And you'd be right. And the way to actually move forward is to find a common denominator, to convert both of these fractions into fractions that have a common denominator.
Okay, 1/115, final answer.
Well, common denominator is going to have to be a common multiple of these two denominators.
1 on
10
top.
and 6. So what's a common multiple of 10 and 6? And it's usually simplest to find the least common multiple. And a good way of doing that is start with the larger denominator here, 10. And say, okay, is 10 divisible by 6? No. Okay, now, is 20 divisible by 6? No.
Just read
Is
that.
30 divisible by 6?
No, you don't.
Yes. 30 is divisible by 6. So I'm just going through the multiples of 10.
1, 1, 15. 15 is the bottom number, 1 is the top number, and it's a mixed
So
number.
I can rewrite both of
Third
these fractions
number,
as
you're
something over
confused.
30. Well, I multiplied the denominator.
Actually, there's a chance that nobody's even
even
watching.
by 3. So I just multiplied the denominator by 3. So if I don't want to change the value of the fraction, I have to do the same thing to the numerator. I have to multiply that by 3 as well. So now I'm just multiplying.
I could say my Minecraft account password and nobody would know because nobody watches.
And 2730 represent the same number. I've just written it now with the denominator 30. That's useful because I can also write 1/6.
However, this guy teaches very well.
Is what? Over 30. I encourage you to pause the video and try to think about it. So what did we do?
1/15.
What is this? 30.
32 over 30, 16 over 15, then 1 over.
Same denominator. Large over 12.
Hold on. 1, 2 plus 11, so. Okay, obviously this one has to be 12. So 6, 1 times 6 is 6. 11, 10, no, 11, 12, 13, 14, 15, 16, 17. So 17, 12. And then 17, 12 will be turned into... So that's... 6. And then that could be simplified to 1 and 1/2.
Over 12. We have 6, 12. And once again, we're going to strangely say over 12. Let's do one more.
1 and 5 though. What did I do? Oh. I got 1 and 6/12. He got 1 and 5/12. Okay, fine. I got that one now.
We're going to have to
I say my GG's
do 1/5.
to people.
You can work it out. What if this is not?
Yeah, this one. 3, 1, I know both of them will be 20. Times 4, so 4, haha, 420, okay. 3 times 5, 15, 15, 19, 19, 20. Yeah.
Divisible by 4. 10 is not divisible by 4. Or perfectly divisible by 4, is what we care about.
I'm gonna go to
15 is
sleep
not
after
divisible
this.
by 4. 20 is divisible by 4. In fact, that is 5 times.
Good stuff. I learned things.